Okay, kicking off the next mini project, and we're starting to get into the meat of the matter. This is the front battery box, designed for huge lead acid batteries that fit in there like a glove, and that sat in this metal frame that went into the frunk. Please feed the YouTube algorithm by giving the video a like. If you want to see more like this, click subscribe and ring the bell to be notified of new videos. If you want to chip in on my expenses, I now have Patreon and YouTube memberships. What I need to do to fit the Tesla modules is they actually need this space here. So I need to cut this, flip it around and re-glue it. Same with that. And the frame also. I have a choice on the frame. I can either just grind this lip off and then have no support in these corners, or find somebody who can weld a new piece in here and remove that, because that will fit in the frunk if it has this piece. I'm searching for a welding guy here in town for that, because I have zero expertise and no welding equipment, but I can tackle this one. Well, as you know, step one is always cleaning, so I got the box about as good as it's going to get. And as I was cleaning, I solved the mystery of what kind of plastic this is. I flipped it over, and it still had the manufacturer's protective film, and it's polypropylene. So I looked that up, and it turns out that it's really hard to cut, as I have already found, and there's two kinds of glue. One is called MMA 500, which is a two-part epoxy that you squeeze out like epoxy. 50 milliliters of that is $30. 50 milliliters is about that much, and I'm going to need far more than that. There's another one called SuperTac 500 that comes as sticks of hot melt glue, and you have a 1/2-inch hot melt gun, and it squirts out the hot glue, and I think that's exactly what we've got here. If you look, this actually has a bead on it, which is probably very similar to that kind of hot melt stuff. So what I get to do to take this apart, I'm going to see if I can just chisel this away to be able to remove that and reverse it, and then glue it back on with some of the hot melt stuff that I've got on order right now. Well, as I suspected, with a chisel and a persuader, I was able to remove the bead of that polypropylene glue from all the edges, and this popped off. Everything's a little rough, but I think once we sand things down, make everything nice and smooth, I will be able to put that back on like that. Then I just have to get a spare piece and cut bottom, and it'll be great. So let's get the other corner off. Well, the other corner was even faster. It took about a minute, so I realized I didn't have to chisel the bead of hot melt glue all the way down. I just had to come in this way and crack it. And so crack, 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 and it just came right off. So, little cleanup. Let's see how it looks. Okay, I got the edges cleaned up nicely with a palm sander and fine sandpaper. That was right, just to polish it up and not heat it up too much where it starts melting. I got all the edges cleaned up, and it turns out that when you put it in place, it's one wall thickness too wide. So I need to trim one wall thickness off this edge. That'll pop in right there. And the same thing right here. Oh, same thing right here. And then that'll be good. Then all I have to do is fill in that hole. Probably fill in that hole. And then I'll see if I can reuse these holes for power and water and data. Seal this up, and then I'm gonna wrap the whole thing because it's all really scratched up, and come up with some kind of really cool vinyl wrap. Well, I just picked up the newly fabricated, changed front battery box. This used to go like that, now it goes like that, and the same over here. For the low price of $287. Thanks, I think. But it's done. I'm gonna spray it black and make it pretty. Then we can install it in the car. And to wrap up the day, 6 p.m. on a Sunday, I installed the front battery bracket in place. It's got two bolts holding it down, and I put a piece of foam in the corners right here because I didn't want it banging against the frame as we're going down the road, and that is not going anywhere. So now I'm just waiting for the hot glue to rebuild this battery box, and we can actually get started with doing battery stuff. Okay, now with the front frame in place and bolted down, I can actually start finalizing the front battery box. What I need to do is put this here and do a very small trim on both sides, right here, and then the hot melt glue for polypropylene just arrived today, along with a hot glue gun designed for it. Then I'll glue these corners in and then make small patch pieces for that. Maybe seal up this big hole right here. Then we'll figure out what to do with the other holes. And then I can start working on battery design. The first patch is cut and fit to shape. Little oversized there, but it's gonna do the job. Luckily, this hot glue stuff is very forgiving. If I screw something up, I cut it, I sand it, it's gonna look good. And I can take as many tries as I need. It's almost like welding metal. I was gonna try and use these clamps, but they're too heavy, so I'm supporting it from beneath. I'll glue along this line. And as AVE on YouTube says, a grinder and paint make me the welder I ain't. And that's going to be pretty much what I'm doing here with my plastic welding. And after briefly reading the instructions, I found this. It is normal for this tool to become quite warm during use. This is normal and does not indicate a problem. That is its whole job in life, is to get quite warm. Thanks, lawyers. Well, I'm kind of disappointed because instead of being hard, the hot melt plastic is like this, and when it melts, it's got the texture of bathroom caulk. It's not rigid. It's not the right glue for this, although sorry, it is holding, but there's always going to be a certain amount of flexibility to it, which I'm very disappointed because I wanted the bead like this thing was originally put together, and all the stuff on the internet said to buy this. Well, as expected, I learned a couple of things. The first one is, in preparation, you should fillet or chamfer the corners that you're working on, the main piece and the piece you're gluing in, to give more of a channel for the glue to lay in. And second, after you do one strip, come right in with a spatula or a spreader and just spread it down. Spread it thin. That gives you a nice smooth surface while retaining a lot of gluing area, because you push it down in the crack and it spreads to both sides. So this one's a little rough. This one will be much better. Okay, this one I just did with the techniques I mentioned, and it looks really good. Do not, and I repeat, do not think that you need to go in and then touch it up afterward. I've watched too many This Old House episodes and watched Tommy teach people how to put bathroom caulk in. You run one bead and you don't touch it. It's the same principle, people. Well, today we had a TV news crew in. They took a look at the shop and they took the Spider for a ride. They've also already done several videos with Jack back in the day, so it's good for them to come back and get an update on the current projects in the state of the shop. The front battery box used to be here, but now it's here. It is fully glued and sitting very tightly into the frame of the battery box holder. And I have also taken the step of mounting the massive DC circuit breaker here, which will go here when I get some screws that are the right size. Let me put some light on. This will go here, and the power will come in from there, here, through here, and then over to the modules. The plumbing will come in there, and then we'll have a pretty good setup here. I just have to work on the mounting straps. Then we should be able to knock this off. I'm going to be filling in the unused holes, and I've ordered a glossy vinyl strip that's 50 feet long that we will wrap this box, and it'll be beautiful again. And you won't ever see any of these seams, which is a good thing. I'll tell you, these Greenlee hydraulic punches are great for making big holes in things like here, until you snap the shaft in half. Focus. So that was fun. Let's see if they have replacement parts. And that was only using the small punch to make the big hole for this 4-aught cable, 2-aught cable. Well, after searching the city for replacement parts for that hydraulic pump thing, it set me back $100. I played around with the front box some more. I made the penetrations in the gland nuts for the DC in, DC out. And over here, this is coolant line in and out. I ordered 50 feet of this particular rubber because it'll slide right over the Tesla connectors in the battery. And I went to pick it up, and the guy says, "Here's your 25 feet of hose." I said, yeah, that was 50, so I get to pick up another 25 tomorrow morning. But then I mounted the DC breaker right here. So when the power comes in, one of them will go to the battery. The other one will come here and out here to the other most negative and the most positive terminal. The cooling is on this side, and all that leaves is the data. And that's about 7 wires in a bundle. But I'm going to do the smart thing, because it's got a honking connector on the end. I'm going to get a through panel connector. So the special EVTV wire will simply go and connect here, and then the panel mount connector will then run to the 3 Tesla modules, which the data connector is over on the same side as the high voltage. So that connector will go somewhere here. And everything, since it's on the front, is very easily accessible in the front space of the battery. The power will come around this side, and the cooling pipes will come around this side. So I'm waiting for this connector, and what I'm going to do now is just fill in all these unneeded holes, and then the box will be ready to go in here when we're getting much closer to the end. All right, I used packing tape, and I taped the back side of the box where all the holes were. I filled the holes in with hot glue and then put a piece of tape over it when it was hot to smooth it flat, and it's actually worked pretty well. This is the next morning. This stuff stayed hot for a long time, but they're nice and solid now. I think I may need to fill this one in a little bit. It's got some gaps, but everything else looks really good. Another thing I learned about filling in the holes, I have 2 places where the hole extends beyond the end of the plastic. So if I tried to fill it, it would just spill out. So I put a layer of tape, a piece of cardboard, held the cardboard in place. Tape, cardboard, hold the cardboard in place, acting like a dam. I filled up the hole, then I laid tape across it, and I did the same thing over here. And it seems to work really well. The glue is mostly self-leveling, but you really want to make sure you fill up the hole and then give it a squeeze, slide over. And I'll tell you, remember that lawyer thing about the glue gun getting hot? Well, the glue stays hot too, so when you rub your finger across, it's going to be pretty hot. So, some of the hazards of doing this work. But it usually turns out really, really well. Nice and flat, fully formed. I'm pretty happy with the way that turns out. Let's peel this off and have a look. Oh yeah, just smooth. Very nice. Oh, there's some squeeze out here, but I'll pull that off with a flat X-Acto knife. I can't believe it. We actually get to start playing with the Tesla battery modules now. I'm so excited. All of that work so far just to get to this point. So, the strategy is 3 of these modules go in here. These are nominally 24 volts, 26 volts. This is the positive battery terminal. That's the negative. The battery management system plugs into this connector. And on this side, we have the plumbing, the in and the out. Doesn't really matter. There's a small set of tubes that go this way that pulls heat out of each cell or puts heat into them, depending on what's needed. Now, also, thank you. Also, each module has a insulating plastic top and bottom to keep everything away from the bad stuff. And as we make a sandwich 3 high, I didn't want to put them one right on top of the other. So what happens is, even in the Tesla, there's an insulating mica sheet or some sort of synthetic material that will go on top. Then a layer of this stiff foam will go between each one. So it's basically insulating plastic, module, plastic, mica, foam, all the way up. That will go in here. Battery terminals on this side, plumbing on this side, stack them high. Then I will make 3 or 2 metal straps that will hold the modules in place this way, and probably also side to side. One that keeps it from shifting this way. The other straps will keep it shifting this way and this way. So let's start stacking and do some measuring. First, placement. We have foam, we have battery module. Did I mention it's going to be tight? I'm going to have to come with some Z bus bars. It's going to use this space here to connect up the stack because I got to go out, up, and in. And then on this side, the plumbing, it's going to be a little easier because the barbs are already pointing the right way. I'll go zigzag my way to the top, come in and out here. Power comes in and out here. Yeah, that's the big challenge in making your own EV, is making things fit. Let's go for another layer. And we have the first meat and cheese in the sandwich. We have a foam pad and a mica sheet, both notched to allow access to the battery terminals. Now we'll put the next module in place. And these puppies are heavy. They're about 25 kilos each, just 50 two 54 pounds each, so I had to put them on a very heavy-duty table because that card table was not going to do the job. All right, let's get number 2. Module number 2, another 50 pounds up and over. Let's make the next sandwich. And here's the meat and cheese in layer 2. One more module to go. Welcome to the completion of the mock-up of the front battery box. This battery box will go into the frunk of that Porsche 914 right there, and its job is to hold these 3 Tesla Model S battery modules. The modules will go here, held down by these clamps, supported with padding and a sheet of mica insulation between the 3, nice and securely held in place. In order to get this to function nicely in the car, we need 3 things to come in and out. We need power, we need cooling, and we need data. The first and most important thing is the power that makes the loop that forms the entire battery pack with the front 3 and the back 3 Tesla modules. These wires, the 2-aught cable, will come up from the back. It will come around here, go through these 2 cable clamps, and then in here. One will come through this massive DC circuit breaker and disconnect, and back around here. It will then go in series with the 3 modules using really cool Z bus bars from Amp Revolt, and that will complete the electrical power loop. In order to keep the modules happy in Spain, they need to be cooled. That will be performed with this cooling loop, cool water in here, warm water back out. The water tubes will come through the heater duct that's on the side of the car. It will come up here, through these 2, and in here. These will daisy chain through the water fittings on the 3 modules, effectively keeping the modules nice and cool under the command of the JevQ of the EVTV V2 box, as I've shown before. The third thing is data. These modules have a daisy-chained data bus that tells the Tesla car computers the state of the modules, their temperatures, their cell voltages, and other interesting things. And we need to preserve that. So the EVTV folks have reverse engineered the data flow, and they know how to talk to these modules, but we need to have a wire. So the wire will daisy chain back and forth between these modules. It will come up here, it will go through this cable clamp, and terminate in this connector. We have a detachable mated Molex connector that will then follow through this hole, and go down here through the firewall and to the back of the car. And I'd like to thank Professor Deacon at Southeast Missouri University, also known as SEMO, for his very generous help in printing all of these cable clamps on their 3D printer setup at the university lab. I designed them, and he printed them. And then I had to redesign them, and he printed them again. And one of the coolest things is the shroud here that covers up the fairly rough hole I had to drill to get this through connector in place. This thing is 2 millimeters thick, and it really nicely finishes off the look of that connector in the front of the box. So I am now declaring this front box done until we actually put it in the car and start putting batteries and running pipes and wire to it. Just before we wrap up, I want to thank my Patreons, Peter Bouvier, and Puppy for their support. We also just popped over 2,000 subscribers, which is quite a nice milestone for my little channel. All support is greatly appreciated. Hey, I hope you enjoyed the video, and if so, please give it a thumbs up. I see that 81% of the viewers aren't subscribed. Please do, as it does help the YouTube algorithm. Take care and see you next time.